Hello friends, today we are going to look at some skills dealing with radicals. Radicals is a fancy math term for square roots. And we're going to learn just some skills that are going to be essential when we get into our solving. Most of this is review, but I just wanted to take some time to walk you through it in case you don't remember every single thing you've ever learned in math over the course of your whole entire life, particularly now during distance learning in a pandemic. So here we go. When you simplify a radical, it's kind of like reducing a fraction. You have to get it into what we would think of as like lowest terms and make sure that you've taken out any perfect squares so that it doesn't contain any perfect squares under the radical. Always look for the biggest one, because otherwise it's like taking, 10 over 20 and saying, oh, I see 2 goes into both of them. And so I'm going to be at 5 over 10. Well, that's not fully reduced. You want to look for the biggest number that goes into both of them and say, oh, 10 goes in. So this will turn into a 1 and this will turn into a 2. And so in the same way that you're simplifying or reducing that fraction, you want to skip any kind of middle steps to avoid having to do it twice. Same kind of thinking here. We want to find the biggest perfect square that goes into it. So sometimes you have to do some thinking. You want to get comfortable with and probably memorize these if you don't already know them. And then you could work on some of the bigger ones with your calculator if you needed to. So what do? I look at 12 and I start with the numbers and I count my way down and I say, okay, none of these numbers can go in because they're bigger. 9 doesn't go in, but 4 does. So I think of this as 4 times 3, both under the radical. This can come out because 4 is the perfect square of 2. So you're thinking, this is what these are going to go back to when you square root each of them, 2, 3, 4, 5, and so on. So then this is stuck under, and now this is the simplified version of that. And so when it says on your tests, quizzes, and worksheets moving forward to simplify your answers, even if it doesn't, the expectation is that you would always simplify what you have going on there. So again, with 76, it's a bigger number. I start looking, none of these go into it, and I get right back where I was with 4, believe it or not, as the biggest number that goes into 76 evenly, and it goes in 19 times. So the square root of 4 comes out as a 2, but the square root of 19 is stuck under there. Here I have a number waiting out in front. Numbers in the front and numbers under the radical don't mix. I always say innies and outies can't mix. So this one just kind of chills out front while this splits into a perfect square and a 3. Sometimes kids ask why you can't use 6 and 2. Well, neither one of those is a perfect square, so it doesn't really help you out because nobody can escape the radical. This can now come out front as a 2. But now these are both outies and they can go ahead and multiply together. So it becomes 6 root 3 when you're finished. Alrighty. Same thing here. I've got the -5 chilling out front. I'm looking at my numbers and I'm thinking, oh, 4 goes into this. And so I go ahead and say, why do these all have 4? I wish they had different numbers. 4 and 10. This is going to come out as a 2. And then this is going to be stuck under here. But now that these are both outies, -5 times 2 becomes a -10 root 10. So simplifying radical is simply going to mean that you're looking for that biggest value. Now we're going to move on to, okay, what if I have to multiply them? Because today's just skills using those radicals. So keep in mind your perfect squares. We can have them from up above and go look at them if we need to. So this is what I was talking about. The numbers outside the radical can multiply. So outies can intermingle. The numbers under the radical, I always call them inside. So those can intermingle. But they can't, like I always say, it's math prison. So if you're on the inside of the root, you can intermingle with the others that are on the inside. But if you are on the outside, then you can only intermingle with those on the outside. So I know you already know how to distribute and that this indicates to do that. So we're going to have to multiply these two. So the root 3 is under a root, as is the root 2. So this number's in the front, and then this one doesn't have anything, so we assume it's a 1. So basically the outies get multiplied to become a 2. Then these inside the root numbers get multiplied to become a 6. And then this also has to get multiplied by the 5. And so that would become this. The 5 is on the outside and the 3 is on the inside, so they don't intermingle. And in this case, it says to write it in simplified form, but I'm looking at it and saying, okay, 6 doesn't contain any perfect squares because I'd be looking for my 4, my 9, my 16, my 25, and so on to fit into there. Nothing does. Same with 3. So in this case, they're done, and I cannot add them together because this would be the same as like 2x plus 5y, in that the radicals are not the same, so you can't add them together and you just leave it as is. The only way I could add them is if they were both root 3s or both root 6s, and they're not. This isn't really distributing. There's no plus or minus, so I don't have to pass it out to multiple terms. I simply have to look at my outside numbers and get a 6 from those. And then my inside numbers will give me a 20. But simplified radical form means that's not going to be a full credit answer. So I have to look for numbers that go into 20 that are perfect squares. Not surprisingly, it's a 4 times 5. So I'm just splitting that 20 up in a way that has a perfect square. So then this can come out as the 2, the square root of 4, and this is stuck under. These two now can commingle and become a 12. And so when I'm all done with my process, these two are the same, but I have multiplied and simplified. Now here, I'm going to have to go ahead and do what I know from the past and do FOIL. Just like in this first problem over here, I knew I'd have to distribute because I have a term in the front and then terms on the inside that are separated by adding and subtracting. So here, if I do first, outside, inside, last, I'll be taking these first two terms. So I'll have 5 times 3, which is going to give me a 15. Then I'll do the outside terms, which is going to be a negative, and then the 5's an outie and the 3 is on the inside, so they don't actually multiply. My inside terms, that's going to be my inside right there. I'm going to have a 3 and then a root 6. And then my last terms, be careful there, I have a positive root 6 times a negative root 3, so I get negative root 18. Alrighty, now I have to remember to simplify. The 15 doesn't simplify, 5 root 3 doesn't, 3 root 6 doesn't, but this 18 at the end is going to be able to split into a 9 times 2, where 9 is the biggest perfect square that fits into it. So that's going to come out as a 3 because the square root of 9 is going to be 3. So that's going to come out as a 3 root and then this 2 that we had. And again, since none of these root 3, root 6, or root 2 are the same, I can't combine them. So if you were thinking of it like variables again, it would be like similar to having, okay, I'm going to have 15 minus 5x plus 3y minus 3z. So since I have all 3 different variables here, here, and here, that's the same as in this problem having 3 different radical values. So I can't put them together, and that's my simplified answer. Okay, if you need a little brain break, go ahead and take it, then rejoin me, or maybe do some practice problems with just the multiplying and the simplifying. But at this point, we're going to take a look at dividing. And dividing is not necessarily dividing. We also kind of call it rationalizing. So let's take a look at what this means. All this is telling you here is that you can make a choice. So you don't get many choices as a teenager in life. Everything's decided for you. But here you can pick. You're welcome. Whether you want to leave it as a whole fraction like in this first example, or split it into 2 radicals, one on the top and one on the bottom. And all I can tell you is that there's a good choice and a bad choice, like in life, which is why your parents always say, make good choices. I would say the same to you right now. So you do whatever helps you the most. So for example, here in this problem, I can't really divide 2 by 25, so that doesn't help me to do it that way. So I'm going to think of it as the square root of 2 over the square root of 25 and split it up like this option, because then I say, oh, root 2 can't come out, but square root of 25 can come out as a 5, and I'm in business. I'm done simplifying or dividing that, even though I'm not really dividing. Here, this looks complicated, so I change it to the other form, because if I think of it as this fraction divided first, then I can see that 98 divides by 2 to become a 49. And the square root of 49 is going to be just a 7. So you have to kind of use some common sense and practice a little bit until you feel like you can say, oh, this is going to serve me better, or this method is going to serve me better. So looking at each of these, like here, I think, okay, it seems to me that I'd be better off if I wrote it this way, because that'll divide to be a 16, which will just become 4 as a whole number. Whoops, that's a weird thing. Oh, well, I like it. I'm leaving it. This one, 7 doesn't divide by 36 so well, so I'm going to split that up and see if that's helpful. Well, that's super duper helpful, because that stays root 7, but this bad boy, the square root of 36, is a regular old 6, so I am donezo, and I've got a much prettier answer, even though I have bad handwriting. Ugh. 18 over 81 doesn't divide, but I'm not sure what exactly, I'm going to get. So I'm going to split them up and manage them each separately. I see that 81's a perfect square, so that's kind of nice. So I know that the bottom just becomes straight up 9, because the square root of 81 is 9. 18 is a pretty big number, and I always have to simplify. So I'm going to look for the biggest number that's a perfect square that goes into 18, and that number is going to be a 9 times 2. Do not cross off these 9s, because the top one is the square root of 9. And the square root of 9 is a 3. So at this point, I have this. Well, everybody in the universe knows that innies and outies can't mix, but now these two are on the outside, so I do still have to simplify those. So I use my math brain and say, well, 3/9 would reduce to 1/3. So my final, most simplified, proper radical answer is going to be just that square root of 2 from here over the 3 from my cancellation. All right, the grand finale for this part 1. So far, what do you have to be able to do? Like, what are your verbs that you need to know how to do? And here they are. You need to know how to simplify. That's going to be something that if you see that verb, you know to get out as many of the perfect squares as possible. You're going to need to be able to multiply. And that's going to be, okay, that's my dog thinking about insides and outsides. That's my other dog. This is the joy of teaching from home. So now I'm going to go hide in my bathroom and finish this. No, I'm going to yell at my dogs first. Hey, guys, we're making videos right now for school, so I need you to be quiet. Okay? Thanks. All right, awesome. Let's continue, hopefully. So then we're going to do, I lost my place a little bit, multiplying, and then our other one's going to be dividing, which really wasn't dividing. It's just choosing between these two options. And then our fourth and last verb for today, because I feel like 4 verbs is a lot for one day, is to rationalize. Rationalize is a fancy term for making sure that you have no radicals in the denominator. It's mathematically wrong to have them in the bottom. This fun fact right here, that's going to be your tool for undoing those radicals, because it's telling you if you take the square root of 2 times the square root of 2, you're going to get the square root of 4, but that's really just 2. And the square root of 5 times the square root of 5 is really just the square root of 25, which comes out to be 5. So if you see that pattern, it's telling you, hey, the root of this times the root of this, the root cancels out and you just get that number. So root 5 times root 5 is regular 5. So I would say if I had the square root of smiley face times the square root of smiley face, the roots basically cancel one another out, because you're looking at taking that root times itself, which is squared, cancels out the root, and you would just get a smiley face. So disregard that last part if it confused you. What that's telling me is that this is the tool that I'm going to use to rationalize my denominators. So in the bottom, I've got a root 2. To get rid of it, I'm going to use a root 2. But in the world of mathematics, whatever you do to the bottom, you need to do to the top to keep everything happy and balanced. So the top, I have an outie and an innie, so they don't mix. Here, these turn into regular 2. But now I do have to pay attention and say, well, these are both on the outside now. So my simplified after I've rationalized answer is regular 2 square root 2. That's going to put everything I learned into play. Same thing here. To get rid of this bottom radical, I have to use the exact same thing. The top, they're both inside, so they'd go ahead and multiply. The bottom will just come out to be a regular 2, and you have to resist the urge to reduce that to 3 because you can't, since the 6 is under the radical and the 2 isn't. Innies and outies don't mix. This one looks really complicated, but the only part that's problematic is this root. So I'm just going to multiply by that part. On the top, both of these values are underneath the radical, so they turn into a 12. The 5 is just chilling in the front. Root 2 times root 2 becomes a 2. So at that point, I have root 12 over 10. Well, that is not simplified because as we learned up at the very beginning, root 12 splits into 4 times 3. So that would become this 2, because that's the square root of 4, root 3 over 10. And then these two are now both outies, and my final answer is 1 root 3 over 5. So nothing is mind-blowingly complicated, but it's certainly a lot of things to remember. This one's messy and confusing, so I'm going to just think of it as root 7 over root 3 because I learned up here that I can go ahead and do that. So then if I have root 7 over root 3, it's not confusing anymore. I know that to rationalize, I can just use that bottom number's exact identity. So on the top, they multiply to be root 21. These turn into a regular 3 because of this rule. Because root 3 times root 3 would be root 9 and become a 3. So then here's what I've got, and once again, you have to resist the urge to say, oh, that reduces to 7 because there's an innie and an outie. The only thing you have to think about is, does 21 contain any perfect squares? And the answer is no, so you can't simplify it. So we know how to, or should know how to simplify. You want to be able to multiply. You want to be able to divide, which really is rewriting and reducing, and you want to be able to rationalize. All of this is review, but all of this is living in a dark, dusty part of your brain probably. So hopefully between me and the dogs, we have helped bring it out of the dusty part of your brain, and you can practice with the assigned IXLs so that you can become an expert on this. And when we encounter it later in chapter 4, you'd be like,